Good morning, everyone. My name is Xiaobo. This paper is about multi-view subspace clustering. By multi-view, it means multiple types of input features. We utilize the constraints of exclusivity and consistency between different views to regularize this task. The first part, motivation. Multi-view subspace clustering aims to partition a set of unlabeled multi-source data into their underlying groups. However, existing works may suffer from the following problems. The first is that some works prefer to learn a common representation, ignore the complementary information between different views. The second one is that the recent work DIMSC explored the complementary information by using the Hilbert-Smith independence criterion. However, due to the scale issue, the HSIC is usually ineffective. Scale issue means that although different representation shows similar block structure, the magnitude of the element values are different. The third one is that most works execute the subspace learning and spatial clustering in two separated steps without consideration of the fact that these two steps highly depend on each other. To address the above issues, we first propose a novel position-aware exclusivity term to solve the first two problems, and a consistency term to solve the third problem. The second part, framework. We first give the definition of our exclusivity. Exclusivity between two matrices U and V is defined as the zero norm of U harmed V. So from the definition, we can summarize two highlights. The first one is that the exclusivity term encourages two matrices U and V to be as diverse as possible, such it can be used to explore the complementary information between different views. The second one is that the exclusivity term is position-aware. If the position ij of U is not zero, the same position ij of V is enforced to be zero, thus it can avoid the scale issue. We use the relaxed exclusivity term, the L1 norm of JV harmed ZW to explore the complementary information between different views, and a consistency term to unify the processing of subspace clustering, where theta is the common indicator. The third part, experiments. Our method achieves significant improvements on several benchmark datasets. The last part, conclusion. A novel position-aware exclusivity term to effectively explore the complementary information between different views. A consistency term to unify the processing of subspace clustering. State-of-the-art performance on several benchmark datasets. Thanks for your attention. Our code has been released on my homepage. Thanks.